We shall go to the next experiment of designing a standalone system in PVSys. Directly we'll go to the website. Before going to the software, let us see various different websites where we can see the information or data in NISC, like National Institute of Solar Energy, under public information, under annual reports. You have the complete details. You can find the complete details here for 2018-19 up to 2018-19. You can download the details. You can also see the data of about the power system in srldc.in. Here the grid frequency right now is 50.03. You can measure the grid frequency using frequency meter in your home right now. It will show 50.03 and it will vary time to time. And you can see the install capacity, total install capacity in CEA, like a central in this website where Central Energy Authority website. The install capacity, when you click on it, you can download the June and July month up to August month is yet to upload. July month details can be downloaded here. Under this, if you download, you can see for Tamil Nadu also, particularly for Tamil Nadu, what is the, here they have uploaded for northern, western, southern and eastern region, what is the thermal capacity, coal, ignite, everything, nuclear, hydro, RES, the renewable energy capacity, total installed capacity can be seen here. See, 88,041.91 is the roundoff value, and these are the things which we can download from the CEA website. We can also see some other data from NREL website. NREL website is a research lab where we can download things regarding PV and also wind. Okay, now we'll go to the software. Under preliminary design, we have the next one called standalone system. Standalone system, we need site and meteor, the horizon, the user needs and the system. The user needs is the additional one apart from the grid connected system. So when I click on site and meteor, I am going to select the same one as I have selected for grid connected. So standalone pre-sizing at Chetty payload, let it be added as new or one. I'm going to save it. Next, the horizon is defined already. I've selected City payload, so it is downloaded from the website. So it is defined. If I want, I can clear the horizon and I can add a new one, azimuth and height for it, if I know the clear data. Next, I have to click on user needs. In user needs, what are the things available in our home? Let me take it as one lamp, let it be two lamps, and let it be one TV, some domestic appliances like three can be added, and each having 50 watts. I am running the lamp for around 5 hours per day. Next, I have one TV which is around 1000 watts and I'm running 8 hours per day. Let the domestic appliances be of 200 watts and I'm running 2 hours per day. Let this be the daily consumption. It can be yearly consumption. We are going to calculate the consumption of these appliances yearly. And total energy spent is this. It is automatically calculated, and I can go for weekend session or week sessions. Let it be like this. And when we go for the hourly distribution, I have to define on what time we are switching on the lamps and what time we are switching on the TV. I have already defined that for lamps it is 5 hours, so I have to check with 5 of any 5 hours. One box is actually half an hour, so 5 hours I'm going to 1 2 3 4 and I can add 1 hour here. 5 hours I've added, and for TV I've added 8 hours, so I'll just drag it for 8 hours. I'm filling it for 8 hours, total 8 hours. For other appliances it is 2 hours, so let me check here. So I've added 2 hours. So everything is done. After doing all this, give OK. Okay. Now I'll go to the system. In system, as we have done for grid connected, I have to vary the tilt angle and fix it as 0. It is already at 0, so I have to find the maximum global on collector plane. It is 2035 as maximum, so let me fix it like this. Azimuth angle, if I vary, the loss factor increases, so let me fix at 0 itself. To check, let me check on optimization. It is at maximum peak. Let it be annual yield, so I'll fix it at annual yield. For annual, the thing varies, so I have to vary the azimuth tilt angle. Tilt angle, let it be at point. I'm fixing here the optimization source. I'm at maximum, so I'm fixing the tilt angle as 15.66 for annually, and so I give OK. The system is done. Clicking on the results, I can see the azimuth angle is -1 degree. I have changed this as -1, so I have to go to the system and let me give it as 0 because it may vary some details here. So click on the system and then results. Azimuth angle is, it is actually tilt angle. Tilt angle is 16 degree. Azimuth angle is 0. The required autonomy, it is nothing but if I have a battery, what is the backup value I need? This is required autonomy. It is 4.0. The required LOL, it is deviation in percentage with respect to the aging. So my LOL is loss factor, which is 5%. Battery system voltage, I'm going to take 48 volt battery, because anyway for grid connected we don't want any battery storage, but for standalone system we need battery, since we don't have the energy content available at night. If you want to switch on the appliances, then we need a battery storage. I'm going to take 48 volt storage, and if you want I can vary it. The array nominal power is 2540 watt peak. Battery capacity is 951 ampere hour. This should be bought. The total investment is which is needed for this is 16 lakh rupees in Indian rupee. Energy cost is 64.35 INR kilowatt hour. If you see this, you will know one thing. In grid connected system, the energy cost is actually 5 or 6 rupees. Here it is 64.35 INR. Okay. So this is the available solar energy for each month, and for when we check the probability loss of load, here I have loss of load for here. So these areas will have current shutdown, I mean power shutdown, and when we click on the next tab, you will get month wise SOC, LOL and the fuel consumption. These are the things. And this is the economic gross evaluation, which is the most needed one. The module cost is around 2 lakhs, battery cost is 5 lakhs 50,000, regular cost, which includes all the maintenance cost, which is 1 lakh around, transporting fitting cost is 7 lakhs, so total investment carries 16 one, yeah, it is around 16 lakhs. The annuities add 80,000 and the maintenance cost add around 1 lakh 37. The total yearly cost is around 2 lakh 17,725. The total energy cost include all these things, so it is around 64.35 INR per kilowatt hour. I can also change it and see here the rate of interest is actually given as 0. Actually it should be 5% at least. So the energy cost increased to 78.70. If you know the exact details, you can edit the cost and see the difference here. This is what about standalone PV system. Just save it. Let it be this. So I have saved it. Thank you.